This is the third and last section, or part of section 4.5, which is 3.6c in the 6th edition. We're going to factor polynomials completely. So we've been kind of doing this already. We'll just talk about it in a little bit more detail. And also mention the factor theorem. Okay, so the factor theorem is if you have a polynomial with degree n, whatever it is, as long as n is greater than or equal to 1, then there are complex numbers so that you can have linear factors, n number of linear factors. So in other words, the number of linear factors is the same as the degree of the polynomial. Okay, and we'll show you that. So for example, this one is a 4th degree polynomial, and so we are looking for 4 zeros, and we will write 4 factors. Okay, now it's totally possible to end up with 2 zeros being the same thing and 2 factors being the same thing, in which case we would put squared, but we still account for 4 of them. So you might notice we have 4th degree, but only 3 terms, right? So if you go trying synthetic division, don't forget to put the zeros in there for x cubed and x. And there aren't very many rational zeros to try. In fact, basically we have plus or minus 1 and plus or minus 2, right? That's it, 4. We try out 4. And there's exactly one positive and 1 negative. But when you try 1 and 2, and I'm not going to work it all out for you, but you could do it if you wanted to, that would be great. But if I divide in 1, it's not a 0, and if I divide in 2, it's not a 0. In fact, so where's that positive 0? Well, then it's got to be an irrational number, right? That's positive. And if it's the positive one, then the negative one's going to be the same deal. So how do we find them? If none of our rational zeros work, how do we find them? And so what you have to remember is that you know a lot of things about factoring. We don't do very many 4th degree polynomials, but we have done some like this when we were factoring, because this is in a quadratic form. It's not a quadratic because it's 4th degree and not 2nd degree, but it's in a quadratic form. So however you want to think about it, we could do like a substitution, right? We could use, say, w, and let w equal x squared. Well, x to the 4th would be w squared and minus w minus 2, which will factor, right? So we have negative 2, positive 1. Okay, and now I could put back in my x squared, and then I can solve them, right? So when this one equals 0, then x squared equals 2, so x is equal to plus or minus the square root of 2. And when I look at this one, I would get that x squared is equal to negative 1, so x is equal to plus or minus I. Okay, so had my 4 zeros, and when I write that in completely factored, it would be x minus the square root of 2, x plus the square root of 2, x minus I, x plus I. Okay, so we have 4 factors 4 zeros, 4 factors. These are completely factored into linear factors. That means the x is to the first degree in all of these. Okay, here's another one. Our possible rational zeros would be the factors of 9 over the factors of 2, right? So we have plus or minus 1, 3, and 9. And we have plus or minus 1/2, 3/2, and 9/2. Okay? All right, so we will start trying them. Okay, we got to find one. So if we do 1, maybe 2, -6, oh my goodness, -6, 3, 3, that one didn't work. So let's try 2. Not 2. 2 isn't even one of my possibilities, so don't try 2. That'd be 6, -2, -6, 3, 9. Okay, so that one worked. All right, so one of my factors is x minus 3. Now I have this quadratic. Okay, so I could see if I can factor. That'd be 6. The first and last multiply to be 6. And is there anything to multiply to be 6 that would add up to be -2? No. So let's go ahead and put it into the quadratic formula. So we would have -b plus or minus square root b squared minus 4 times a times c over 2a. Okay, that would be, have to come up here a little, plus or minus, we got 4 minus 24, so that's -20, and that would be, pull the 4 out, minus 2 square root of -5, which would be an I. Oops. All right, so pull a 2 out of everything. We got 1 plus or minus. Actually, let's go ahead and do 1/2 plus or minus square root of 5 over 2i. All right, this would be my other 2, so that would be x minus 1/2 minus square root of 5 over 2i, and x minus 1/2 plus square root of 5 over 2i. All right, that would be completely factored. Okay, let's look at this last one, see if we have enough time to do it. What are my possible zeros? So I have factors of 1, which is just 1, over the factors of 4. So I'd have plus or minus 1 over 1, plus or minus 1 over 2, and plus or minus 1 over 4. All right, well, you know, we have to try 1 first. Man, I don't know why I'm getting so many. Okay, so if I try 1, 8, 8. Oh, wait a second. I don't want to try 1. Let's look at this a little bit closer. How many positive zeros are there? Do you notice that all the signs are positive? There are no negatives, so that means there are no positives. Yeah, I don't want to try any positive numbers. I just want to try negative numbers. So let's try negative 1. So that'd be negative 4, that'd be 0. And 1 times 0 is 0. And then negative 5, negative 1. Negative 1 times negative 1 is positive 1, so that did not quite work. Alright, so what else do I have? I'm left with being forced to try fractions, right? That's all there is. Oh dear. Negative 1/2. So bring down the 4, and that is a positive 4. And negative 1/2 times 4 is negative 2, so add that, that'd be 2. And negative 1/2 times 2 is negative 1, so that would be 4. And negative 1/2 times 4 would be negative 2, so that'd be 2. And negative 1/2 times 2 is negative 1. Alright, so I have 1. It's x plus 1/2 because negative 1/2 is my 0. Alright, well I already know that negative 1 doesn't work. And I already know that none of the positives will work. So let's just try negative 1/2 again. And I'm just writing it down here where I had left off because that's the part I need to use. Those are the numbers I need to use. So negative 1/2 times 4 is negative 2. That'd be 0. And that'd be 0, and that'd be 4. And negative 1/2 times 4 is negative 2. So that's 0. Right, so I know that there's 2 of these, right? Now I have 4x squared plus 4. I want to find out where that equals 0. Let me factor out a 4. And I would have x squared plus 1. And I think, if you recall, when we solve that, it's got to equal negative 1, which is I and negative I. Alright, so I know that I'm going to have this factor of 4. I can just put that in the front, right? And then I'm going to have x minus I, and I will have x plus I. Okay, this is what it looks like completely factored. Okay, I end up with this 4, and I know I have this 4 because in the original problem there's a 4 here. And normally if we just find all of our zeros and write them as factors, we'll end up with just an x there. And so that's why we multiply by that 4 to give us the right numbers. And when we multiply these out, I would end up with a 1/4 because of this 1/2 here. Okay, so this is what it would look like completely factored to linear factors. Alright, here's your quiz question. So I want you to completely factor this. So this is just like the ones that we've done. If you wanted to do this by grouping, you could factor this by grouping. You know how to do it. Or you can factor it by finding one of the zeros and doing the division, and then with the rest of what's left, the quadratic that's left, you could go and put it into the quadratic formula. Okay? Or just solve it. It depends on what it looks like. So when you write your answers, I want them written as factors, not just as zeros, as factors. So you got to write x minus the 0, each of the zeros. So you should have 3 factors, put them in parentheses. Don't put any spaces inside. Don't put any spaces or symbols between the factors. Just put the factors next to each other with their parentheses.